Welcome dear students for the second segment of our lesson. Our lesson is changes in matter part 2. First of all, I am going to discuss with you what are combustible and non-combustible substances. Combustible substances. The substances that can be burned are known as combustible substances. So we can take some examples for that. Camphor, wax, sulfur, sugar, liquor, paper, tar. Those are we can consider as the combustible substances. What are non-combustible substances? Non-combustible substances are the substances that cannot be burned, are known as non-combustible substances. So my dear children, we can take some example for that. Asbestos, glass, sand, rock, those are we can consider as the non-combustible substances. Now, next we are going to talk about what is combustion. What is combustion? You know that very well. The reaction of combustible substances with oxygen is called combustion. The special feature of the reaction of combustion is it's a chemical reaction as well as releasing thermal energy, that means heat and light energy. There are three main factors essential for combustion. So if you want to burn something, we need three things. What are they? What are the factors for essential for combustion? One is presence of a combustible substance. We have combustible substance. The other one is oxygen gas. We need oxygen gas for combustion. Heat in the combustion substance, combustible substance to the ignition temperature. What is ignition temperature? Now we are going to talk about. So these are the three things for combustion. Now we are going to talk about what is the meaning of ignition temperature. So my dear children, ignition temperature. The temperature at which a combustible substance begins combustion in the air is called ignition point or ignition temperature. So my dear children, a combustible substance starts to burn after it's heated to its ignition temperature. So, the substances which burn early, so it has low ignition temperature. If it is high ignition temperature, it takes long time to burn. So, this is the relationship with the ignition temperature and the combustion. Now we are going to talk about, my dear children, the next new thing. This is a symbol. You can see the symbol here. That symbol in this side we can see there are red colored strips like triangular shape, heat, fuel and oxygen. Then this is we can name as a fire triangle. What is known as a fire triangle? The relationship among the factors required to create a fire is known as the fire triangle. So, that is a symbol for fire triangle. Now we are going to talk about to extinguish a fire, it is required to. What are the things we need to prevent the fire or extinguish fire? So, these are the three things. Prevent the access of oxygen. You have to prevent the access of oxygen too if you want to extinguish a fire. The other thing is prevent reach in the ignition temperature. We have to prevent it when it comes to the ignition temperature. The other one, remove the combustible substance. If you are removing the combustible substance, we can prevent we can extinguish the fire. So now we are going to talk about. We use to extinguish a fire is throwing water sometimes. If there is a fire, we are putting water, we are throwing water. So when we are putting the water or throwing the water, what are the things, how we can extinguish a fire? So first heat from that fire, then the ignition temperature goes down. Then that is the way we can extinguish a fire throwing water. Now there is another instance now we are going to talk about. What is this? When somebody clothes catch fire, the most suitable method is extinguish a fire of that person to roll on the ground. What has happened there? Break the connection between the air and the material. Combustible substance, the material that has got fire, then we can extinguish a fire. So that those are the ways, those are the instances we can apply how to extinguish fire using throwing water or rolling on the ground like that. Now we are going to talk about fuels. There are 3 types of fuels. What are they? Solid fuels, liquid fuels and the gaseous fuel. Fuels are substances used to generate heat, energy and light energy. Because of when we are combust fuel, we can get heat energy and light energy. So what are solid fuels? We can take the solid fuels, examples, firewood, coconut husk, coconut shell, wax, those are we can consider as the solid fuels. What are liquid fuels? Kerosene, petrol, diesel, coconut oil we can take as liquid fuels. What are gaseous fuels? So we can take some examples for gaseous fuel as liquid petroleum gas, that means LP gas, coal gas and methane we can name as another name as biogas. So those are the types of the fuels and their examples. Now we are going to talk about identify the product from during the combustion of fuels. You can see there is a setup. You can see a candle and the beaker and the tube and a bottle. There's an aspirator. So what is the way, what is the thing that we are going to prove in this practical, through this practical? So we need a candle, a bottle, glass funnel, a U-tube, lime water, we have to use there lime water and copper sulfate and hydrous copper sulfate. It's white in color. So what is the thing that, what is the method that we have to do? So you have to light the candle and you are using the glass funnel. Then you have to take the, you have to expose to the product of the combustion of the candle. Then those products goes through this and it goes to the anhydrous copper sulfate and it goes up to the lime water. First of all, you have to activate the aspirator. Then when it is lighting the candle, all the air, all the products goes through this setup when we are opening the aspirator. Then after few times you can see as observation, anhydrous copper sulfate becomes blue in color and lime water in milky color, milky. So those are the 2 observations you can see when you do this activity. So what are the conclusion? Why the anhydrous copper sulfate, white in color anhydrous copper sulfate turns into the blue in color? Reason, it absorbs, anhydrous copper sulfate absorb water vapor and it becomes to blue in color. And lime water becomes milky. So why the lime water becomes milky? Because when combustion of the candle, carbon dioxide gas is produced. Because of this carbon dioxide gas, it goes to this setup and it dissolves in the lime water, then it becomes milky in color. It's milky. Then we can get the conclusion. What is the conclusion? Because of the combustion, carbon dioxide gas is produced as well as water vapor produced. So those are the 2 conclusions we can do. We can prove because of doing this activity. Now we are going to talk about complete combustion and incomplete combustion. What is complete combustion? What is incomplete combustion? My dear children, what is known as complete combustion of fuels? We are talking about that. The combustion occurring an adequate supply of oxygen. That combustion we can name as complete combustion. What are the results of complete combustion? We can take carbon gives carbon dioxide, hydrogen gives water. More heat is produced because of the complete combustion. Then we are going to talk about what is incomplete combustion. If the combustion occurs with inadequate oxygen, that is we can name as incomplete combustion. Because of the incomplete combustion, we can get carbon gives carbon dioxide, not only carbon dioxide, carbon monoxide and unburned carbon particles. As well as hydrogen gives water, same as the complete combustion. Low heat is produced. These are the, when you compare, these are the things we can get because of the incomplete combustion. When you are comparing the complete combustion and the incomplete combustion we can get more heat than incomplete combustion. So that is the complete combustion and incomplete combustion. Now we are going to talk about you can see in here the candle flame. So when you observe the candle flame, if you are lighting the candle, then you can observe the parts. So you can see the base part is as blue zone, and inside non-luminous zone and the luminous zone. The outer area we can name as an outer zone, that is barely visible. If you are talking about the parts in detail, you can see what will happen when the candle is burning, when the candle is lighting. When the candle is lit, solid wax turns into the liquid wax. You can see solid wax turns to the liquid wax. And liquid wax moves up through the wick and vaporizes. This is the wick. Here wick. Then using this wick, it vaporizes. The wax vapor reach with oxygen and produce heat and light. You can see when we are lighting the candle, we can get heat and light both. Now, if you are talking about the non-luminous zone, that is the inner zone, as well as contain wax vapor in the non-luminous zone, and the temperature is low in that zone. If you are talking about the luminous zone, this area you can see it's lighting color, it is a yellow color, as well as unburned carbon particles are there, and the temperature is little high in the luminous zone. Outer zone, now you can see the outer zone, the base part is blue zone, appears in blue color at the base, hardly visible in other areas, and has the highest temperature. In this outer zone, it has highest temperature than other zones. Those are the parts of the candle flame. Now we are going to talk about parts of the Bunsen flame. So you have seen Bunsen flame. You come to the lab, so you can see the Bunsen flame. So there are different, when we are talking about the parts of the Bunsen burner, you can see there is a color, air core, and the gas tube, and the foot, and the stem. So those parts we can see in the Bunsen burner. When we light the Bunsen burner, that we can take the Bunsen flame like that. You can see this is the non-luminous zone. Then dark blue zone, light blue zone, and invisible zone around that you can see there. So when the oxygen supply decreases, okay, what will happen? We can see the yellow in color flame. If the oxygen supply is increased, we can see the blue in color flame. That means complete combustion occurs. Non-luminous zone. Non-luminous zone. It contains unburned carbon particles, the carbon gas. There are another we discussed dark blue zone, light blue zone, and as well as invisible zone. That invisible zone, it occurs complete combustion. Those are the parts of the Bunsen flame. Now we are going to talk about tarnishing of metals. What is tarnishing of metals? When metals are exposed to the air for a long time, what will happen? The luster disappears, the shine disappears. That is, we can get that phenomenon we can name as tarnishing of metal. Then what is rusting of iron? Now see, if you are putting iron nail or any the material made of iron, if you are putting into the outside or environment, if you observe after a few weeks, you can see some rust on those materials. Rusting of iron. Iron rust is formed on the surface of iron due to tarnishing. That process we can name as rusting of iron. So, what are the factors essential for rusting of iron? There are two factors need for rusting of iron. One is air. Air, the composition of air. If you are talking about the composition of air, we know the hydrogen, carbon dioxide, and nitrogen, oxygen gases contained. We need, for the rusting of iron, need only the oxygen gas, and the other one is moisture. Now, oxygen gas, moisture need for rusting of iron. Now we are going to talk about investigate the air is essential for rusting of iron. So how can we make that practical? We can take the 3 test tubes like that, and we have to use the clean iron nails. Then we have to enter this, putting the iron nails into these 3 test tubes. For the test tube A, we can use boiled water. Test tube B, we can use cold water. Test tube C, we can use the cold water. Once again, for test tube A, we have to put test tube A and B, we have to put a layer of coconut oil like this. Then, if you keep that set up for 2 weeks, around 2 weeks or 3 weeks, you can see some observations. What are the observations? The nail in test tube A, you can see, does not rust. What is the reason for this? Because the air cannot enter to this test tube to dissolve in the boiled water, because there is a coconut layer act as a barrier. Then, because of that, those 2 iron nails do not rust. The second one, B, test tube B, you can see that also little rust, but why? Because this is cold water. Inside the cold water, the air has dissolved there. Then, because of this air, it causes for rusting iron nail. When we talk about the iron nails which in the test tube C, you can see those iron nails are rusted blood. Why? Because it is there is no any coconut layer act as a barrier, and the air in environment can dissolve inside into the cold water. Because of that, the iron nails face for rusting. So this is the practical that we can prove to investigate. Air is essential for rusting of iron. So that is the practical that we have to do. Then we are going to talk about the other one. What is the other factor, my dear children? Moisture. So how can we prove the moisture is essential for rusting of the iron? So this is the setup that we have to arrange. So you can see inside there are the calcium chloride crystals. So I want to show you, these are the calcium chloride crystals. So we have to prepare the setup like that. So you have to take the boiling tube or test tube. You have to put the calcium chloride there inside the test tube, and you have to arrange the nails like this. The pointed part and the flat head likewise you can arrange. Then when you are keeping that sort of test tube for few weeks, you can see the outer parts of those two nails have rusted, but inner part does not rust. Why? Because the calcium chloride absorbs all the moisture inside this boiling tube. So the boiling tube, because of that, the outer part has rusted, but inner part does not rust. So that is the practical that we can prove. The moisture is essential for rusting of iron. So my dear children, so you have to remember, when you are doing that sort of setup, you have to put some amount of wax around this mouth of this boiling tube. Why? It acts as a barrier to prevent moisture into the boiling tube. So that is a practical that we can prove the moisture is essential for rusting of iron. Now my dear children, we are going to talk about ways of protection of iron from rusting. So what are the ways? So you know, we can apply application of paint. We can apply paint for prevent rusting of iron. So like the grills and gates and bridges, so we can apply paint for preventing of rusting. And application of grease. You know, the grease we can apply the grease to prevent rusting some sort of machinery parts. And by galvanizing, what is galvanizing? By applying metal on an object made of iron. So because of that galvanizing process, we can protect from rusting of iron. So we can use buckets and the roofing sheet iron nails for galvanizing to prevent rusting of iron. Then the other application of tin metal. So in the sardine tin or milk powder tin, the tin metal has applied. So those are the methods we can use to protection of iron from rusting. Now we are going to talk about neutralization. What is the neutralization? There's a practical you can see there. Now I'm going to show the things that you have to do. Then neutralization. When an acid is added to a base or base is added to an acid, that is process we can name as the neutralization. So because of acids and the base, if they are react together, the neutralization reaction will occur. So I am going to prove this. We can take the sodium hydroxide. You know, sodium hydroxide is the strong base. You can see that. Then I am taking dilute hydrochloride. That is strong base. The other thing that I am going to use to explain neutralization reaction is a sort of indicator. What is the indicator? You can see the indicator like this. That indicator is that I am going to use phenolphthalein. That indicator, when it is in the base medium, it becomes to the purple in color. If it is in the acid medium, it does not show any color. So how can we prove this? How can we do this activity? I am taking sodium hydroxide base, the solution, the base, and I put in some amount of phenolphthalein, that means 2 drops. You can see the color change. What is the color? It's the purple color, dark purple color. Then, this is hydrochloric acid. Now I am going to add dropwise to the sodium hydroxide solution, the hydrochloric acid. Then what will happen? It has the basic property, it has the acidic property. Now when you can see the color has disappeared. Phenolphthalein, the color has disappeared gradually. Why? Because the color has disappeared in this upper part. You can see gradually it will disappear because there is no acidic or basic property in this mixture. Now it has made sodium chloride and water. So if you take a little time, you can see that the color has totally disappeared. Then, my dear children, that process we can name as neutralization. So now we are going to talk about in day-to-day life. Day-to-day life, the neutralization reaction will occur. So what are the instances? Now we are going to talk about. Those are the instances. One is, if you are suffering with that is acidity inside your stomach, what is the thing that you are going to do? You take some amount of milk of magnesia. Why? That inside your stomach, hydrochloric acid there. Then when you are taking the milk of magnesia, that is base, then when we take some milk of magnesia, some 2 or 3 spoons, then you can get inside your stomach gets neutralization. Then no acidic property, no basic property inside your stomach. Then you can feel very comfortable. Then the other one, the pain caused by bee stings disappear on application of lime. Then if there is a bee sting on your skin, then you can feel little pain. So how can we prevent that pain? So we have to, if you are applying some amount of lime on there, because you can feel very comfortable. Why? The lime is base, the bee sting is acid. Then it will face for neutralization. Not only that, the wasp stings is a basic. That sting is, if it is venom of the wasp stings is basic. So if you are applying some sort of vinegar or vinegar or the lemon, then you can feel comfortable because it will neutralize. So those are some instances that we can discuss under the neutralization in day-to-day life. Then that is the part that we discuss today about the changes in matter. Thank you and God bless you, my dear children.